All right, here we go. Our objective for today, I can solve multi-step one-variable equations involving proportions. Read together. 1, 2, 3. I can solve multi-step one-variable equations involving... So today we're going to revisit proportions. You guys already saw this before, but I'm revisiting. And just to get us more up to speed in regards to what we're doing with proportions this year in algebra. Okay? So we don't need a fair amount because we already know what one-variable equations are. Is that correct? Yes. We already know the steps to solve one-variable equations. Simplify, isolate, plot, check. Okay? This next part is just so that I can refresh in your memory in regards to some of the terms you already know and we're revisiting. The first one is a ratio. Ratio. Once again, you don't have to copy this. If you want to copy this, up to you. A ratio is a comparison of two quantities. And let me show you the different ways to write a comparison of two quantities. Look up, please. The first way is writing it like this, comparing A to B, and it's pronounced A to B. That's a comparison. It's a ratio. Another way of writing it is like this, with colon. And it's also pronounced A to B. Bless you. Another way of writing it is in a fraction form, and then it's also pronounced A to B. Everybody with me? The only thing, if it's written in a fraction form, the denominator cannot be 0. Yes?
But how do we know, like, it's a problem? Like, where to say, like, A over B, like, the ratio?
They'll say the ratio of this to that. It's always going to say the two word, the word, where is it at? The word to. It's going to say. It's kind of like saying the ratio of girls to boys in my algebra advanced class is, and then I just give you some numbers. Does that make sense? Yeah.
Okay, what about if it's just like a problem, like, it's just like 2, and then it's like A over B, something like that. Like, we don't know if it's a ratio or a...
Well, the ratio is just two quantities, and it's usually the same kind of quantities. So we're talking about, let's say, baseball cards over baseball cards. Girls to boys, they're both people, same kind, okay? And let me show you the difference between a ratio and a rate. Look at a rate. A rate, let me first explain proportion. Proportion, all it is a ratio equal to another ratio, or in other words, a fraction equal to another fraction. Everybody understand?
Yes.
Okay? Let me go to number 3. A rate is a ratio of two quantities with different units. Look at this one. Miles and gallons. Different units. Do you guys see that? Mm-hmm. This is distance, and this is more of a measurement of liquid. Who can think of another rate? Who's heard of another rate? Nina. Miles per hour. Miles is distance, hours is time. Those are two different measures. Does that make sense? Those are rates. Okay? Now, if I was to give you this rate, look up, and I ask you to minimize this to lowest terms. Look at it. What would be this minimized to lowest terms, everyone?
No, 17 miles per hour.
17 miles. Be nice. 17 miles per hour, and that's what we call a unit rate because we minimize one of them into a 1. That's why it's called a unit rate when you simplify something to lowest terms. Okay? You good? Okay? Yeah, go. All right, so now that we have our terms, this is what I'm going to be talking about today. Copy this one, example 1A, on your paper. It says, read that for us, please, Matthew, loud.
The ratio of the number of bones in a human ear to the number of bones in the skull is 3 to 11.
Mm-hmm.
There are 22 bones in the skull. How many bones are in the skull?
Okay, copy that, please, and then we'll go over this really quick. All right, let's see.
I'm not even done. I'm not even talking.
Caleb is like, hold on, Mr. Q. Example 1. No, I was elaborating. All right, here we go. Okay, look up, please. Whenever you encounter some of these problems that are word problems that talk about ratio or rate, on these you don't really have to do the cubed process. This one has a little bit more of a direct way of approaching these with a proportion. So watch. The way you do these that talk about ratios is like as you follow. I'm going to read it first. It says the ratio of numbers of bones in the human's ears to number of bones in the skull. How many different things are they talking about here? 2. Bones in the ears and bones in the skull. So to differentiate one from the other, I'm going to underline the first one that they mention in red, which is the ears, and the second one they mention in blue, which is the bones in the skull. Why do I need to know that? Because with our ratio, look up, 3 to 11, that tells me which number corresponds to which. Therefore, which of these corresponds to the ears? Everyone. 3. So I'm going to underline that in red. That means the 11 is for the bones in the skull. And why do I need to know that? Because when I set up my proportion, now I set up a proportion, so I make this into a fraction. 3 over 11 equals a blank. So, let's read the question, or the information they give us. There are 22 bones in the skull. I'm going to underline that in blue. Therefore, the 22 corresponds to what? To the 3 or to the 11? To the 11. That means I'm going to write the 22 in the other fraction on the denominator, right? And now in your noodle, you can actually get the answer. Is that correct? Okay, I don't want that for right now. What I want us to do is practice proportion. So this is going to be our x. And how do we solve this? Revisiting this from past years, cross multiply, starting with a variable. What is 11 times x? 11x equals, what is 3 times 22? 66, and now we can solve this, yes? Divided by 11, x equals 6 bones in the ear. Yeah.
Is that true?
I haven't checked, but this is some information that was already in the program. I'm pretty sure it is, yes. Well, there you go. Bam. Everybody understand how to break this down? Yes. All right. Do this next one by yourself. You don't have to copy the word problem. I just want you to set up your proportion and solve. Here it goes. Example 1B. It says, the ratio of red marbles to green marbles is 6 to 5. There are 18 red marbles. How many green marbles are there? Set up your proportion and solve. Go. So let's see. Give me your proportion, Jasmine. Go. Uh-huh. Cross multiply, so this is 6x, and this is 90. Divide by 6. X equals 15 green marbles. Hands, if you got that? Okay, yeah.
Can we, since 6 and 18, they're both divided by 18 by 3 to get 6, can't we just put times 3 on the top and the bottom?
Did you ever hear that?
Yeah.
Yes.
Are you sure that doesn't work?
But no. For right now, I want you to use the cross multiplication because this is where we're going. Yes, Jeremiah.
Does it matter if you put 18 on the bottom?
It does matter. Because if you put the 18 on the bottom, you multiply this times 18, you'll get 108. And then all of a sudden, divided by 5, it's not going to give you this answer. You see what I'm saying? Yes.
What'd you say?
What Hannah was saying is that, look at the previous one I said. The previous one, once we have 22 here, you saw, 11 times 2 is 22, therefore 3 times 2 is what? 6. Yeah, we can do that in our noodle. But this is why I want us to practice the cross multiplication, because when we get to this one, copy this one. That's why we're not going to be able to do that one on this one, okay? So here we go. Example 3A. 6 over y minus 3 equals 2/7. Do we have a proportion? Yes. So it says there, let's see, a fraction equal to another fraction. And we always start with a variable. Is that correct? Variable is right here, so it means we're going to cross multiply this. But not only that variable, because now the variable has another term here, we include it in the cross multiplication. Therefore, what do I write here, everyone?
2y
Minus 6, because we do multiply the second term. And this is equal to 42. You know what to do from there, yes? So from here we add 6 to y equals 48. Divide by 2. Whoa. Y equals 24. We get this, yeah? Okay, do the next one by yourself. Yeah. It's going too fast?
Yeah.
Cross multiply. So we cross multiply the 2 times the y, but now the y has a second term. So 2 times y is 2y, 2 times negative 3 is negative 6, and 6 times 7, that's 42. Yes? Okay, do this next one, please. 3b, we got g plus 3 over 5 equals 7 over 4. Copy that and go. Would you help me with this one, Hallie? What do I do? Okay. Yes, but g plus 3 times 4. So what do I write here? Thank you. And you know what to do from there, yes? Minus 12 minus 12. 4g equals 23, Michael Jordan. Divide by 4, divide by 4. Therefore, g equals 5 3/4, or 5.75. Hands, have you got that? Okay, good. We got these, yes?
Yeah.
Okay, yeah. No, I said or. Yeah. Felipe.
How do you decide which number's gonna go on this side?
Usually, I make it a rule. I always start with a variable, so that's what I always write first. Yeah.
Okay, for the home place, is it 2.5 or 25?
2.5.
Okay.
Oh, you guys want 25?
No.
No, it's only 14. Only 14. All right, so look up, please. Now, we're done with those. Let me show you how to do a unit rate before I give you the last part of the home plate. Look up. Check this out. Don't copy this, just pay attention. It says, Ralph Lau of Germany flipped a pancake 416 times in only 120 seconds. It says, find the unit rate. Look up, please. To find the unit rate, which means I want to find out how many times he flipped it in how many seconds. 1 second. That means I'm going to write here what? X, so that's 120x equals 416 divided by 120. X equals 416. 120 goes in there 3 times, 360. Subtract, that's 56. Add a decimal. It's in there 4 times. I'll stop right there. It's approximately, he flipped for every second 3.4 times a pancake. So let's see, let's try it. In 1 second, let's flip a pancake 3.4 times. Ready? 1, 2, 3. That's hard, isn't it? 1. That's crazy. Anyway, so please, if you go into the restaurant business, you're going to have a tough competition with people like that. So, really quick, look up percent. For those of you that didn't know, it's a compound word. It has 2 words in it. Per means to multiply. Cents, everybody seen one of these? Yes? Which means 1 over 100, which in turns, if I gave you 25%, what does that mean? 25 times 1/100. Does that make sense? All right, so with that said, look up. For when we get to percent problems, look up. When we get to percent problems, I know some of you can just multiply times percent and so on and so forth. But for the purpose of practicing proportions, I want you to write this proportion, please. Yeah, some of you already seen this before. Copy is over of equals percent over 100. Okay? Is over of equals percent over 100. Is over of equals percent over 100. Hold on. Look up. So how does that work? It works like this. Is over of equals percent over 100. Blank over blank equals blank over 100. Which one didn't change? The 100. What information did they give us? 30%. What else? 80. Therefore, this is cross multiply and solve. Play sheet over here. 2.5 is up here. There's tutoring today. Be nice. Oh, if you have your media release form, bring it in. No, only numbers 1 through 14. Have a good one, guys. Enjoy your home play. See you guys. Tamales.